Kita mulai aja mungkin. Udah jam 8 menit.
Ya,
Ya.
ntar Jumatan lagi ya, mepet.
Nggak sampai sesiang itu sih. Ya. Bismillahirrahmanirrahim. Good morning, dear college. Thank you so much for investing your time with us on a wonderful Friday morning. I'm Nuke from Research Unit of Statistical Economics, and I'm serving as moderator for today's monthly research discussion. Today, we have an amazing panel consist of panelists. The first is Mrs. Ika Yuni Wulansari, SSTM Stat, that will talk about small area estimation for count response data, empirical bias Poisson Gamma. And the second is Dr. Ahmad Syahrul Khoir, SSTM SE, that will discuss about the neo-normal distribution and its properties. But before we dive into the panel introduction and presentation, I want to take the temperature of this room. How many of you are familiar with small area estimation topics? Maybe you could raise your hand. No? Is there any?
Bumpo.
Oh yes. I'm sure like some of you already knows about this topic. And how about how many of you are familiar with the neo-normal distribution? Neo-normal distribution. Please raise your hand. I think this will be an interesting discussion. Okay, so our goal today is that whatever you are familiar with those topics, small area estimation topic, the neo-normal distribution, or you are not familiar with that, you will come away with something, a new idea, a fresh perspective that you can increase your knowledge and maybe apply to your next research. So here's the format to give you an idea of what to expect in this discussion. We will start from the first panelist, Mrs. Ika Yuni, and then we will take a few moments for her to briefly introduce herself and tell a little bit about her background and research interests, then continue to her presentation. After that, we continue the same pattern for the second panelist, Mr. Ahmad Syahrul. And then the second half of our time today, we will open up the floor to give you an opportunity to ask specific questions that you've been thinking about to help you navigate the upcoming opportunities and challenges of these topics. Sound good? Okay, great. Let's get started with our first panelist, Mrs. Ika Yuni Wulansari. So please, the time is yours.
Okay, thank you, Ms. Nuka Widowati, for giving me chance and opportunity to sharing my knowledge about the small area estimation and the uses of Poisson Gamma model for count response data. First of all, I want to highlight my research background and my specialization may be in the small area estimation because I've been doing this research since in the bachelor degree, and I continue to study this research in my master thesis, and inshallah, I will use this method too in my research PhD. I mean, so that's my research background, and in this occasion, I'll share a little knowledge and a little our contribution to small area estimation for count response data by using the R package that I and my student have built, and that's available in Quran, and we can use it publicly. Okay, I will directly to present my sharing knowledge about Poisson Gamma, count response, small area estimation for count response data, empirical based Poisson Gamma, and I'll make sure that this is working. Okay. Can you see this slide?
Yes, clearly.
Very clearly, thank you. Yes, this is what our will be discussed about. We highlight the count response data because the typical count response data that not normally distributed, and it's qualitative or discrete data. So we have to be careful to make the estimation, especially for small sample estimation or small area estimation. And we'll approach the estimation by using Bayesian methods, using Poisson and gamma distribution. Okay, this is the background of this method. Samples for national survey is often obtained for national level estimations, but nowadays we are directed to decentralization, and we need the estimation for regional, district, or even sub-district estimation. So the samples of national survey is insufficient to provide the estimation at the small sample or small area. Because not reliable estimation when we directly use those samples, and we will lack of precisions of the estimation. On the other hand, we need additional budget to add sample size and need longer time to data collections. So the idea of SAE, small area estimation, we can employ the indirect estimation by borrowing strength from neighboring area and auxiliary information correspond to the area that we want to estimate. This is the idea of a small area estimation. So we just use the existing samples at the small districts or small area, and we combine those samples combined with the modeling, or we can say that it's so-called indirect estimation, the combination of design-based and model-based. For example, when we want to estimate the household expenditures, we can improve the precision of estimation at the sub-district level by using sample of Susena's socioeconomic surveys as the design-based, and we improve it by adding auxiliary information, for example, from village potential data or BODES, and we make the combination to make small area estimation. And the most characteristics of PPS survey data is count response data. So we can use empirical base or EB, Poisson, gamma, to provide reliable estimation at the small area. Okay. First of all, I want to introduce about the indirect estimation because I have stated before here. The indirect estimation is, this is the jargon that usually used in this research. Borrowing strength, this is a very popular jargon. SAE modeling is highly dependent on the strength of the auxiliary variables that correspond to the variable interest. And then based on the availability of auxiliary variables, SAE can be divided into two, namely unit level and area level. SAE area level is SAE modeling with the available auxiliary variables at the same level as the desired estimation result. Meanwhile, the SAE unit level is SAE modeling with auxiliary variables that are available below the level of the estimate carried out. SAE modeling that's often used is the SAE area level because the auxiliary variables usually available at the area level. for example, district or sub-districts. As I mentioned before, usually we employ the Saya area level because in Indonesia, we only have the PODES, village potential data, that have a complete list of the information in the smallest area, which is a village in Indonesia. So in Indonesia, the research of SAI majority developing in the area of SAI area level at this time. Okay, and we move to empirical base or EB. Before going through EB, I would like to mention here the EBLUP. EBLUP is empirical based linear unbiased predictor. That is the regular SAI method applied to linear mixed models. However, the linear mixed model is designed for continuous variables, so that's not suitable for binary data or count data. For binary or count data, the EB, empirical base, and hierarchical base, or HB, are used to perform SAI. Those are using the Bayesian method on its estimation. And then we will focus on EB. In the EB method, the lack of information to determine the prior distribution causes parameter estimators to be more influenced by information from the data or empirical. So the EB method uses the information from the data or information from the observation as empirical prior. So that's the difference between EB and the HB. EB is half base and the HB is fully base. So in the EB is more easier than HB because it only uses the distribution from the data or uses the empirical prior from the observations. And Pringle in 1995 states that the advantage of EB method is that produces relative risk estimator that's more reliable than the maximum likelihood estimator and is able to accommodate information between areas or borrowing strength within areas in order to reduce the mean square errors of the estimation. And we move to empirical based Poisson gamma. This is the most frequently used EB methods, that is Poisson gamma model. The Poisson model is the standard probability for count data, as we know, Poisson distribution. However, in an over dispersion condition where the expected values and variance are not the same, it can be overcome by taking additional information on the prior distribution to overcome the excess variance from the observations. As we know that the Poisson distribution has the characteristics that the mean and the variance has the same value, lambda. So we have to take into account the additional information on the prior distribution to make sure that the condition is equidispersion. Yeah. One of the prior distribution that can be used is the gamma distribution, so that the Poisson model becomes a two-stage model, namely Poisson gamma model. Okay, we will elaborate more about it in the next slide. Wakefield introduced Poisson gamma two-stage model, as I said before, to estimate parameter in count response data. So we will elaborate what is the meaning of two-stage model. At the first stage, it's assumed that the random variable YI has Poisson distribution, or we can written as like this. YI, distributed Poisson distribution, this is the parameter. And this is the PDF or probability density function of YI. YI is the observations or the data that we collect from the samples. Okay, this is the PDF of the Poisson, as we know. And if we see here, the PDF of YI contains mu and x mu and what I mean is mu e. Mu e is the function of x, e, and beta, and this is the regression model where we can collect the xe. Is it the factor of covariates or auxiliary information? Usually in Indonesia, we can use the PODES, yeah, village potential data, and beta here is the factor of regression coefficient. As I mentioned before, when we used SciA modeling, we borrowing strength from auxiliary information to modeling SciA. So this is very critical to select the strong auxiliary of variable. So usually, firstly, we examined the correlation coefficient among the auxiliary informations and the variable of interest. And the second stage, it's assumed that the parameter theta has gamma distribution or can be written as theta e distributed gamma with the parameter alpha and alpha. This is the PDF of theta I. And we can see that this is a gamma distribution with mean 1 and the variance 1 over alpha. So that is the definition of the Poisson gamma. To sum up, what we mean as Poisson gamma model, that we estimate the parameter by using two-stage model. The first stage we define this, and the second stage we define this. Yeah, this the meaning of Poisson gamma. And based on the first formula and the second formula, we can obtain the third formula. This is the PDF, the joint PDF of the observation and the parameter. Because we assumed that those we assume that ye and theta e is independent, so we can make a joint PDF by multiplying them. This is the joint PDF, and then from this we can get the marginal PDF of ye as follows. And when we see here the marginal PDF of ye, it's negative binomial distribution, yeah. The distribution of negative binomial with mean and variance are as follow. This is the mean and the variance. So we can estimate the posterior distribution for theta I or theta in ith areas using this formula. This is the estimate of posterior distribution for theta. And based on the formula 5, we obtain the posterior distribution of theta is gamma, as we see here. This is the PDF of gamma distribution. So the posterior distribution for theta is gamma. We can written as this. This is the distribution of theta. Thus, the posterior mean and posterior variance are obtained as follows. This is the posterior mean, and this is the posterior variance. The posterior mean can be presented as this, based on Wakefield. I'm sorry, this is Wakefield 2006, not 2007. And this is the estimated. This is the hat. So this is the estimated of theta I empirical based. This is same with the previous slide. If we see it here, it's the same. And we can write in the formula like this. it's gamma. Yeah, no, it's not the same with gamma distribution, but the gamma here means the weight or the portion or contribution, the direct estimation and the indirect estimation. The psi modeling will successful if the portion or weight of an indirect estimation bigger than the portion of direct estimation. It can solve and describe that we use the auxiliary information well, so it improves the precision. So we can evaluate whether our modeling is good or not good enough by the gamma coefficient. And Wakefield 2006 used the expectation of relative risk, as I mentioned before. Poisson gamma used the relative risk to improve the precision and reduce the mean square error. Okay, this is the relative risk, mu cap. This is the exponent of the synthetic model, and this is the indirect estimator. Okay. And for estimation of MSE, mean square error, Poisson gamma, as we know that the jackknife method is widely used to estimate the MSE. So we cite the Jiang et al. 2002. And this is the formula to count the MSE. It consists of two components, M1 and M2. Yeah, okay, and all of those formula we have tried to publish a package in our package that we called PSI-EB, and it's already available in Crunch. So if you interest to know about it, and you can look forward in the R documentation. Look for and look into the R documentation. In the package, there are two functions, EBCOF and EBNOCOF. EBCOF is empirical base using covariates, and the EBNOCOF is EB Poisson gamma without covariates. But EBNOCOF is rarely used, yeah, because we want to increase the precision by borrowing strength from auxiliary data. So we often use the EBCOF rather than EBNOCOF. And this is the explanation, the documentation of EBCOF. This is very simple. This is the arguments, consists of formula. It's like a linear model, the formula. And then the data that we used, and the EE, that's the expected number of cases in each area. In this opportunity, I'd like to give an example, the implementation of the EEB, Poisson gamma, to estimate the number of births by adolescents. The number of births by adolescents, this can be collected from the SDKI data, and jumlah lahir, yeah, the number of births of adolescents. And when we check the distribution of the jumlah lahir, this significantly distribute Poisson distribution. So we can employ the Poisson gamma model to estimate the number of births by adolescent in each district in Indonesia. Also, we also have to collect the strong and rigorous auxiliary information. Yeah, we use the PODES, the village potential data, to select the significant auxiliary information. Yeah, and this is the auxiliary information. And the most important thing that we want to include the auxiliary information that we should we should doing a literature review first. Yes, so we can make a justification that by theoretical background or theoretical framework, our auxiliary information is has a strong relationship or has a strong connection relation with the interest variable, and this is the results of our selected variable, jumlah desa, jumlah sekolah, vaskes, nakes, and etc. And then we employ the EB Poisson Gamma, and we find this result. If we see here, say Poisson Gamma improves the precision, we can see that the RSE of the Saya Poisson Gamma is lower than the direct estimation. This is the RSE of relative risk, yeah, of the number of adolescent births per district or city in Indonesia, which is consists of 515 districts based on SDKI data on 2017. And when we examine further in the gamma coefficient, we'll see here that among districts in Indonesia, the gamma coefficients differ each other, and we can see it is a very heterogeneous, yeah, very heterogeneous about the gamma coefficient. So when we see the average gamma is 0.3844, so the Saya Poisson gamma performs well because the 1 minus gamma is more than 50%, yeah, or more than 0.5, yeah. So we can conclude that our indirect estimation is our indirect estimation performs well or can improve the estimation. But we have a note here. We have to take into consideration about the variability, yeah, of the gamma. It indicates that in different districts, we have to concern about the auxiliary information. Yeah, maybe one auxiliary information is not suitable in another districts, so we can look it further, yeah, by examining the auxiliary information that we used. Okay, this is the reference that I used in this PPT, and if you interest more about it, you can visit our package, and you can start to try. And because in this package we also provide the dataset dummy, lip cancer, and if you have any questions, we can discuss in this research discussion. Okay, I think that's all. Thank you so much.
Okay, thank you very much, Mrs. Ikayuni, for the interesting and informative presentation about small area estimation, SAE, specifically for count response data using empirical bias EB Poisson Gamma. I'm sure that many of you have something to say or something to ask, but please hold on. We will wait a moment. Maybe write it down, just not to forget the question, or put in the chat box, and we will discuss it later in the question and answer session. For now, I would like to continue to the next panelist, Dr. Ahmad Syahrul Khoir, SST-MSc, that he will discuss about the neo-normal distribution and its properties. So please, Dr. Ahmad Syahrul, the floor is yours. Please unmute the microphone, please.
Okay. Thank you very much, Bu Nuka, for this event. I will present our research. Before that, forgive me, my English is still Jawa English. That maybe there are mixed with bahasa. Okay. My name is Ahmad Syahrul Khoir. My research is about Bayesian method and the computation about Bayesian. There is my publication. It's my research is about MSc Pure distribution, properties and estimation, and then you extending run checks. It is the packet R packet to running checks for Bayesian computation. This is a tutorial to adding module distribution to checks software through packet run checks. I research about general regression neural network, that this weight or parameter estimate by Bayesian approach. There is one book about SRA using Bayesian network. It was published by Andi Jakarta. Thank you. Okay, now I will present my presentation. This is about neo-normal distribution and its properties. What is the neo-normal distribution? Neo-normal distribution is a distribution, relaxation of the normal distribution, or the approximating normal distribution. For example, relaxation of normal distribution, there is exponential power distribution. In this distribution, normal distribution is relaxing over kurtosis. The normal can be modified. The normal distribution modified. That this can platycortic, mesocortic, and leptocortic. There are skew normal distribution. It's a relaxing normal distribution about its skewness. In the in this distribution, the normal can be skew. Anzalini proposed this method, this distribution. The characteristic of this distribution is the mode is switched to other location depend on the parameter skewness or alpha. The other distribution is a skew normal distribution proposed by Castillo. In this distribution can be skew and can be normal, but this mode is still on zero. This mode still on zero, not depend on skew parameter. Another distribution is Tukey's GH. In this distribution, Tukey add the two parameter, parameter to skewness and parameter to kurtosis. Parameter of kurtosis. G parameter is for skewness, and H parameter is for kurtosis. In Tukey's GH distribution, this distribution can be skew and can be more kurtosis. Kurtosis can be large and low. It can be verticortic or leptokurtic. Another distribution is beta normal distribution. This is combined beta distribution and normal distribution. The CDF of normal distribution is equal to distribution of beta. This combination, namely beta normal distribution. The unique characteristic of this distribution, this distribution can be have two mode. Distribution can be have two mode. It can be one mode and can have two mode. Another method of lessing is for approximating normal distribution. This distribution is MSN-Pur. MSN-Pur distribution was proposed by Prof. Iriawan on 2000 as new normal distribution. It can be skew on left or on right, positive or negative skew. While parameter skewness is positive, it's this can be positive skew, while below one, it is negative skew. Above one, it can be positive skew, but if parameter skewness is 1, it can be symmetries. This distribution modifying by modifying for type 2. It is a general distribution of logistic distribution. A special case of type 2 is logistic distribution. This is a CDF of the for type 2 distribution, while alpha is 1. This distribution is logistic distribution. This distribution modified, so it become this. In this distribution, the mode is not depend on alpha. So Iriawan called it stable, modified to be stable. Distribution have three parameter: location parameter mu, scale parameter sigma, and shape parameter alpha. Shape parameter is a control of skewness. The CTF has an inverse, so it can be generate data by using inverse transform method. The shape parameter is used to determine the skewness of distribution. This is the graphic, while below one is negative skewness. The MSN4 distribution can approximate the normal distribution when alpha equal to 1, but the tail is fatter than the normal distribution because while alpha equal to 1 is like approximate logistic approximate to normal, like logistic approximate to normal. We know that logistic distribution fatter than normal distribution. But the magnitude of positive skewness is not as big as negative skewness. The negative skewness can be more than positive skewness. So I propose, this is a CTF and PTF, GTF and PTF of MSN4. So I propose the MSN4 to a distribution. This was modified by modifying for type 2A distribution. CTF4 to a distribution is modified, so it becomes this distribution, this CTF. This distribution have three parameters: location parameter mu, sigma, and shape parameter. And this is a CTF of MSN4 2A. Same with MSN4. The CTF has inverse, so it can be generated data by using inverse transform too. Same as the MSN4, the shape parameter is used to determine the skewness of the distribution. MSN4 to a distribution also can approximate the normal distribution when alpha equal to 1. But the magnitude of negative skewness is not as big as positive skewness. Positive skewness is more than negative skewness. This is CTF and PTF. CTF in closed form, we can get PTF by different derivative of CTF. The properties of MSN4 the mode is mu. The location parameter is mode. Its mean depend on three parameter: mu, sigma, and alpha. It's more complex than this mode for mean. Its variant sigma quadrat is different parameter sigma and sigma square per function of alpha and T gamma alpha plus T gamma 1. Yes, this is a formula of skewness. From this formula, we know while alpha equal to 1, this skewness is 0. It means this is, while alpha equal to 1, this distribution is symmetries. It is a formula of access kurtosis. This is a quantile. It's inverse of CTF. Is inverse of CTF. The characteristic mean variance, kurtosis, and skewness is derived from moment generating function and is cumulant generating function. There are relationship between MSN-Pur and MSN-Pur2A given Z as distribution MSN-Pur with parameter alpha, mu, sigma. If y equal to minus Z, then y is following distribution MSN-Pur2A. If alpha in MSN-Pur and MSN-Pur2A equal to 1, then both distributions are close to normal distribution. This is MSN-Pur versus MSN-Pur2A. It's a different characteristic. In MSN-Pur, more skew on negative skewness than positive, and MSN-Pur2A more skew on positive skewness than negative skewness. If the alpha equal to 1, this distribution can approximate a normal distribution. But the tail is still fatter than normal distribution. This is the skewness from alpha, depend on alpha, skewness depend on alpha. While MSN-Pur, negative skewness can be -2, but positive skewness a little above 1. In MSN-Pur2, positive skewness can be 2, but negative skewness little below -1. So I developed the other distribution is namely GMSN-Pur, generalized of MSN-Pur. This distribution can be perfectly close to normal distribution, and it can be skew on negative skew or positive skew will in same value, same magnitude. Okay, thank you very much.
Okay, thank you, Dr. Sahrul. That's all exactly what I need to hear when I got the title of your presentation on neo-normal distribution. So let's continue to our second terms. I will open 2 rounds for all of you to comment or ask question to our panelists. And I will collect the question first, then I will invite the speakers to comments on or answer the question. For the first round, is there anyone who want to start? Please raise your hand or drop the question in the chat box. I will read it for you, but I would be glad if you can ask the question directly to our panelists. Is there any? I'm sure that these topics are really interesting. Is there anyone?
Okay. Thank you.
Oleh
Okay.
Pak Timbang, please.
Maybe Siti Maria first.
Okay.
Ladies first.
Okay, please, Ibu Siti Maria.
Yeah, thank you so much, Bunuke. Yeah, I have some questions for both speakers, and actually the materials, the topics are very interesting, and my questions, I think this is, I have some, and these questions are maybe for you stupid questions, because I just want to the basic, the fundamental, asking like a newbie in statistical modeling. So the first questions maybe is assigned to Bakayun. So you said that the distribution of the Y variable should should be Poisson or gamma distributions. So it depends on the, the distribution of the Y maybe will lead the kind of modeling or the kind of distribution we will use in the modeling. But how about if we don't know in the real world, we don't know the distribution of the Y in the population? So I mean, can what we have to do for the first questions? And the second, in some statistical modeling, I see that when they want to evaluate the model, because maybe we don't have much mini samples, so we use jackknife or permutation or bootstrap resampling method to understand or to calculate the mean square error. It is quite different in machine learning. I know that's different in machine learning. We talk about the prediction, and this statistical modeling we talk about estimations. But in terms of validation, we want to understand the performance of our model. Why don't we use the validation? Why don't we measure the mean square error or other performance metrics or other measurement back to the back to the ground truth? Back to the real value. Because in my limited knowledge, that we know that in a small area estimation we have limited samples. So and when I read some paper, when compare and when we develop one model, the author always compare with direct estimate to understand is it better, the result is better or not. But we know that the limited sample, instead of using the direct estimate, is also not good choice. Why it compared to the direct estimate? Why we don't compare the true value in terms of unit level? Maybe unit level estimation, not area level estimation. And then the third, I'm sorry, I have so many questions. This is maybe stupid questions. And the third, when we look for the auxiliary variables, I see in your codes that you use the linear regression. Is it right, Mbak Kayun? And I think how in and you say and you said that we also have the domain knowledge, theoretical knowledge to see to search for the auxiliary variables. In case that, okay, the domain knowledge, I understand that this variable will correlate, but the correlation is not linear. can we use, can we use non-linear regression on non-linear modeling instead of the linear regression? Okay, I think that's all the questions for Mbak Kayun and for Pak Ahmad Syahrul. And this is again stupid questions. Why we need? Why in statistical modeling we need assumptions that error should be normal distribution or residual should be distribution, or data that we want to estimate? Why we have to attach assumption that the distribution should be normal? Okay, that's a very stupid question for me. And the second, when we can use the neo-normal, in what condition instead? Yes, I see that if we plot the data, okay, I know that this is normal or this is neo-normal, but is there any excuse, or is there any conditions or circumstance that we should use the neo-normal? Yeah, I think that's all. I'm sorry so much questions.
Thank you, Ibu Siti Maria, for wonderful question. I think there are none as stupid question. There will be no stupid question here, because we will discuss. And I think most of your question represents my question also. So we are in the same boat. But before the speakers respond to this, please, Mr. Timbang Sirait, if you have any question.
Okay. Thank you, Bu Nuke. Thank you to all of you presenters, Bu Ika Yuni and Pak Syahrul. But my question only to Bu Ika Yuni. Related to your presentation, just only one I would ask to you, Bu Ika. In small area estimation, we borrow strength power across both small area and time. Maybe you can explain how we can get the strength power from the small area estimation, especially for the explanatory variable. You use PODES by PODES, okay? Maybe you can explain, especially to me on others today admit in your presentation, how we can get the explanatory variable that relate to the response in small area estimation that the model you can make. Okay, thank you.
Thank you, Pak Timbang, for the question. So I think just for this question, there are from Ibu Siti Maria and Pak Timbang, and there are 4 questions in total for Ibu Ika Yuni, and then 2 questions for Bapak Syahrul. So please, Ibu Ika Yuni, to respond the question. Hello.
Okay, thank you, Bu Nuke, and thank you for.
Kok putus?
Wow. Maybe Bu Ika Yuni's technology is out. I couldn't hear your voice.
Tes. Bu Kayun?
Hello, am I audible?
No, not clearly
Hello,
yet.
am I audible? Hello?
Yeah. Now it's clear now.
Test. Okay, thank you.
Yeah.
I'm sorry for the connection trouble.
Yeah.
Yes, thank you so much for the, wow, that's very tough questions, very difficult questions, I think, for me. And I'll try to answer. The first question comes from Bu Siti Maria. Of the distributions of interest variables. Yeah, yeah, that's true that in the small area estimation, in the development of the methods of small area estimation, it depends on the distribution of the interest variables or the distribution of y variables, yeah. And the distribution of that interest variable leads to different methods of estimation. Maybe we can use the fully Bayesian estimations if we not want to trap into the distributions. Yeah, maybe we can employ the HB, hierarchical Bayes method. It more complex, but more what we call flexible in the terms of assumption distribution. And what's interesting questions about how, when we don't know the distribution, I don't know too at this time. How if we don't know the distribution, because the distribution is very important, yeah, in order to justify where are the best methods, yeah, that fit with those distributions. And then about the jackknife and bootstrap, in order to infer the MSE. Okay, that's interesting questions. Yes, that's right. The jackknife and bootstrap is the numerical methods, yeah, or approximation methods to estimate the MSA. And the, if I don't mistaken, in the research paper of Wakefield 2006, he said that the Bayes method is asymptotically unbiased estimator and empirical based as well. So he recommend a jackknife method to be used to obtain asymptotic unbiased estimator of MSE of the parameter. So that's why in this presentation I use this method, jackknife or bootstraps. We can use one of those, yeah. And about the questions, auxiliary information, yeah, auxiliary informations, yes. At the example of my presentation, I use the linear regression as the pre-treatment, yeah, pre-treatment before employing psi models, because we have to make sure that the auxiliary information that we take into the model is strong and rigorous enough, yeah. First, we have to check the theoretical knowledge or the conceptual background. Yeah, that's right. And then we check the empirical based on the correlation of the Y and auxiliary variables. Yeah, it's right. That correlation it's linear, linear correlation, but how that, hello?
Sorry, Ibu Ika, maybe you can turn off your video to improve the audio.
Okay, I'll turn
Thank you.
off my video. Okay, thank you.
Now, would you please repeat for the third question?
Okay.
Okay.
Thank you. Yeah, the auxiliary variables that I use. Firstly, I examine the relations of the auxiliary variables and the variable of interest using the regression. And we have to make sure that the auxiliary information that we take into the model is is a strong and irregular auxiliary information, so it can improve our model. But above all, theoretical knowledge or theoretical conceptual background is the most important of above all. So even if in a linear regression there are variables that not different, we can still use those variables if based on theoretical knowledge or theoretical background is significant. So the most important part is the theoretical knowledge about the relation of the auxiliary information and the interest variable. And it's like interesting questions about how if the correlation of auxiliary variables and interest variables is not linear. Yes, and it often we have to know that in a SI model, the important part is the relation or the relation, yeah, not have to linear, but among X and Y or Y variable have can use auxiliary information, yeah, because if I said previously that the most important part is theoretical knowledge or theoretical background to select the auxiliary information. Okay, and then about the comparing with the direct estimate, why? Yes, in a lot of literature, yeah, in a lot of literature, we compare the indirect estimate and the direct estimate. It sounds silly, yeah, because oh yes, indirect estimation should be performed than the direct estimate, but the goals to compare it to illustrate that our proposed indirect estimate performs better than the direct estimate, just to show that, just to illustrate that. In unit level estimation, using the area level.
Halo Ibu Ika Yuni.
Experience in a unit level estimation.
Hello. Would you please repeat from the part, the last part?
Me?
Yeah, because I think we have
Hello,
trouble.
Banda.
Hello, Tess. Can you hear me? Ibu Kayun.
Masuk area blank spot.
Aduh, gimana ini lah? Sorry. Ibu Kayun, tes. Are you still there? She's kicked out from the room. So while we wait for Ibu Ika Yuni to join with us again, maybe I'll just continue to Pak Sahrul, Bapak Sahrul, to respond to question from Ibu Sumarda, please.
Thank you. Thank you. Okay. Normal assumption reason, yeah, the reason. It's because the method to estimate parameter or the inference based on this assumption. Why we need check the normal assumption. While we develop estimate parameter on inference use another distribution, we have to check normal assumption. I think why we need a normal. Usually we use ordinary square. This method have assumption the residual is distributed normal. So we need this distribution, normal distribution to check in the data and the residual of regression. But normal is the distribution that can be normal or not normal. So we need we don't about as normal assumption, because while the residual normal or not, it is the model is robust, but the distribution of residual. For example, there are outlier. The outlier, the normal distribution can solve the problem. I think we can model directly without check the assumption of normality. But this assumption not normal usually more easily if we estimate using Bayesian method, because in the Bayesian tidak dibatasi gitu. Nah, there is no better have to normal. We can use any distribution in the inference about hypothesis testing or computed interval. We can use any distribution if we use Bayesian method. Thank you. I think this is enough. If not clear, we can speak bahasa Indonesia saja.
Oh. But I think it's already answered the Ibu Siti's question, I think. So maybe we could get back to Ibu Ikayuni that haven't finished the answer session yet because she's kicked out from the room. Ibu Ikayuni.
Yeah.
Yeah. Please continue to answer the last question from Mr. Timbang, I think.
Okay, thank you. I'm sorry because of the connection problem. I don't know. It's not usual. It's unusual. Okay. Yeah. I try to answer Mr. Timbang question about knowing strength. How we can get the strength of the power of explanatory variables, yeah. And in small area model, we take into account the random effect area as the way to borrowing strength from neighboring area. And then we also take into account the strong auxiliary information in the model. Maybe I'd like to share again my presentation in order to show where the explanatory variable improves the estimations. Yeah, okay. And here we can see here that based on Wakefield 2006, yeah, I'm sorry for, this is 2006. We obtained the expectation of relative risk as indirect estimator. And this is the exponent of auxiliary information and beta. And from this, we know that we employ the auxiliary information to estimate the relative risk. Okay, this way we mean borrowing strength from auxiliary information. Okay, I think that's the explanation, yeah, about borrowing strength from auxiliary information. Okay, thank you.
Okay, Bu Ikayuni. Yeah, relate to your auxiliary variable, and you take from the PODES. What variable can we take from PODES that we use to our models, especially to your models?
Okay, thank you, Pak Timbang. Can I answer directly, Bu Nuka?
Yes, please.
Okay, thank you. Yeah, thank you, Pak Timbang. There are a lot of variables, yeah, available at the PODES, and we can select variables. First, we have to collect the literature review, where's the variables that have a relation to our interest variables, and then we collect those variables in the one data set, and we examine the empirical correlations, and maybe we need to use the linear model, a stepwise regression, for example, a linear model, to examine those relationships. But it's not a complementary, or it's not have to do. We can use the theoretical background or conceptual background to select the auxiliary information. Yeah.
Okay, thank you. Thank you very much for the explanation from both panelists in the first round. Maybe we can continue to the next round. We have some question in the chat box, but before that, is there anyone who want to ask directly?
It's me, I am.
Yes, please. Who is this?
Pak Rindang.
Oh yeah, Pak Rindang. Sorry.
Thank you very
I
much.
can message. Yeah, please, Mr. Rindang. Then we can go. Then after this, we go to the chat box, please.
Okay, thank you very much, Mbak Widawati. I will ask to Mbak Ikayuni. We know that all of survey include SUSENAS or SDKI must contains sampling width that it's determined based on a complex sampling design to represent a population. I think the sampling width should be not be ignored in the modeling, especially for estimating the number of events in the count data or Poisson data for Poisson distribution for the small area. So how do you include the sampling width in your model or on your package, R package? And the second question for Mas Sahrul Khair, what is the weakness of the neo-normal distribution when we use it in the modeling? Maybe related to formula derivating in the frequency side or the computational time in the Bayesian perspective. Thank you. That's enough.
Thank you very much for a question from Pak Rindang to Ibu Ika, Yuni, and Bapak Sahrul. I read in the chat box that Ibu Tio is the one who raised hand first before all those questions. So please, Ibu Tio.
Thank you, Bu Nuke. My first question, I think already asked by Pak Timbang to Bu Ika Yuni about the borrowing strength. Yeah. So now I will ask to Pak Sahrul. Because this is a topic for me, so I want to ask about the definition. From your presentation, neo-normal distribution, you define as a distribution as a relaxation of the normal distribution. From this definition, for me, it is still not clear. Yeah. Why? Because, for example, like a T distribution, I think many people will know the difference between normal and T distribution, because the symptoms, sorry, not the symptom, yeah. The characteristic of T distribution, for example, outlier data and heavy tail, something like that. But the new normal still for me still unclear. Can you give example what actually the main difference between neo normal and normal distribution? Why I'm asking this? Because, for example, if we have data and then we false in categorize the data, actually this is neo normal, but we categorize it as normal distribution. Is there any effect on that? For example, in parameter estimation. And my next question, is there any software for detecting this new normal distribution, or any method that we now our data is categorized as neo-normal distribution? Thank you.
Thank you, Ibu Tio, for the question to Mr. Arul. Before that, I like to collect the question from the chat box also to include in this second round. The first is from where Ibu Cucu Sumarni. Why don't you use for Ibu Ika Yuni? Why don't you use Poisson regression instead of linear regression when selecting variables? And then from Bapak Aska to Mas Sahrul, what kind of real data from BPSS an example that can be applied to the neo-normal distribution, MSN BURB? And then to Ibu Ika, why the parameter of Poisson is mu and theta mu? And why only mu that has the link function to the linear combination of auxiliary variables? So these are the two the all question for the second round. Please, I would like to go to Ibu Ika Yuni to respond the question first.
Okay, thank you, Bu Tio. Okay, there are so many questions. Yeah, maybe I want to answer the question from Pak Rindang first about the design sampling, yeah, of the survey. Yes, that's true. That's right. I agree with that. That we have to considering about the design sampling, because when we use the sample size, we use the sample from the survey, it depend on the estimation should depend on the design of the sampling survey. Yeah, and in small area estimation, we employ those methods in a design based, yeah, in the direct estimation. in the direct estimation, we estimate the YE, using the design of the survey itself. So, for example, when I estimate the YE from the SDKI as a direct estimation, I use the package survey from Lumley, if I'm not mistaken. And using those package, we can determine the sampling design, whether it's 2-stage, 1-stage, stratified, etc. And I'm sorry, I'm not included in my presentation because I intend to focus on the indirect estimation, which is the EB Poisson gamma. But yes, in our process in processing the data, we should include the design of the sampling method. Yeah. Okay, and then for the question from Bu Cucu, well, that's very, very nice, very great feedback for me. Yes, that's true. It should use the Poisson linear model. Yeah, maybe it can give a better results, yeah, instead of linear regression model. And then we can compare also, yeah, when we do a preliminary examine using the linear regression or Poisson regression too. Yeah, thank you so much for the feedbacks. That's very positive feedbacks, and I'll add it in my paper. And then questions from Pak Aska. Well, it's a very difficult question, yeah, about the parameter of Poisson. Why the parameter of Poisson is mu and theta, and why only mu that has the link function to linear combination of auxiliary variables. I'm sorry, I don't know it clearly, but because I adapt the model from the Wakefield 2006, but in my limited knowledge, if I'm not mistaken, the empirical base or EB is a half base method, not fully based. So in the Poisson distribution, there are two parameters, mu and theta, but the original or the genuine parameter is the theta, and then mu is the synthetic synthetic component, yeah, that consists of auxiliary information and coefficient of regression. I think that's all in my limited knowledge. Okay, thank you.
Thank you very much for the response, Ibu Ika Yuni. Let's continue to hear the response from Bapak Sahrul. There are three person who asked the question, from Mr. Rindang, and then Ibu Tio, and Bapak Aska. If you miss some question, we'll help later in the discussion. Please,
Okay.
Bapak Sahrul.
Okay, thank you. I answer first Bu Tio questions. The definition of neonormal distribution. In neonormal distribution is not unique distribution, but it's a class of distribution. There are many distribution that can be jadi anggota ya dari distribution. There are many distribution can be called neonormal. In the first presentation, I explained several distribution. First, relaxation of normal as in skewness. Normal distribution only symmetry, but Azalini relaxing the normal distribution, so the normal can be symmetric or skew. So this can flexible for data, but Azalini only relaxing in skewness.
Excuse me, Pak Sahrul, maybe you can louder your voice.
Okay. There are many things about relaxing distribution, normal distribution. In the first, relaxing about skewness. Azalini do it. Subbotin relaxing about kurtosis. The distribution on symmetric, but this kurtosis is modified by Subbotin, so it can be normal, can be mesokurtic, but it can be leptokurtic or latikurtic. But Tukey is modified to characteristic skewness and kurtosis. With diffusion we use to the data. We can compare any distribution by we think it's fit to the data. We can compare it based on the characteristic, maybe from histogram or the other. We can compare both ratio likelihood or AIJ and another measure. Especially of non-normal, distribution can be normal. Jadi can be normal or not normal. Maybe data normal is okay, not normal is okay. Jadi not usually normal, not usually normal. With software we can testing we can use R. There are a package can be estimate parameter and testing about using Kolmogorov-Smirnov. We can compare this between Kolmogorov-Smirnov. Second question for Mas Rindang.
Yes, about the weakness of neo-normal in modeling.
Neo-normal.
Yeah.
In first of all, normal distribution has easily can be estimate using maximum likelihood estimator, but there is distribution is too problematic if using MLA. So it's depend on the distribution, the weakness. But especially my distribution, I failed to estimate using maximum likelihood. So I use a Bayesian method because the cost of the flexibility is need more usaha, need more usaha untuk for estimate, because my formula is so complex, so I failed to use MLE, maximum likelihood. But using Bayesian is more easily using Bayesian because the programmable language, the language to program language to estimate is there are many software can be used. There are many software can be used. using Bayesian method. That is not clear or clear, Mas Rindang?
I think we can continue to the
Very
next
clear.
question.
Very clear. Thank you.
Okay. Next question, Mas Aska. I haven't explored PPS data that fit the MSN Pur 2A, my distribution, but I think MSN Pur 2A it fit to positive skew data. So I think data manufacture, large, medium, should be fit to my distribution. I think enough.
Okay. Okay. Is there, before I continue to additional round, maybe, is there any comments from the one who asked question before, from Ibu Tio, Pak Rindang, or Pak Aska about two panelists' response? Do you want to add comments? I think it's enough.
Okay, Bu Nuka.
Oh yeah, please, Pak Aska.
Thank you. My question to Mas Sahrul is enough. That we can apply the new normal distribution to the manufacturers data. To Mbak Ika Yuni, that say that mu is only a synthetic parameter. I think if mu is a synthetic parameter, it is a high risk, to link the mu directly with the auxiliary variables. As we know that the linear combination of auxiliary variables must be normal distribution. So the parameter of Poisson is positive, positive value, and if we directly connecting the mu to the linear combination, we can trap, we can trap trap itu apa itu, terjebak ya. We can trap to the value of the negative value. And one question again, in the area level, in the area level, as usually we get the variance of the MSA of direct estimation. So in this package, how we put the variance of direct estimation in the model, sorry. Okay, thank you, Mbak Nuka.
Yeah, thank you very much for the comments, and an additional question to Ibu Ika Yuni about how we put the direct estimation in the package. And maybe just to wrap up the discussion in this morning, please also respond to one question from Ibu Cucu in the chat box. On second stage, gamma, alpha, is the alpha estimated or known? If known, how do you assign the alpha? So please, Ibu Ika Yuni.
Okay, thank you, Bu Nuka. Maybe to make it clearer, I want to share again my PPT. This is the maybe flow chart, maybe flow chart to build this package. And as corresponding to the questions from Bu Cucu, yes, we count alpha, we estimate alpha using this formula. And then questions from Pak Aska about the yes, that's right. It's lead to high risk, yeah, when we directly linked the mu to the combination linear of explanatory variables. In the research paper of Wakefield 2006 that we make as benchmark reference, he used the exponential form in a binomial negative binomial regression, and he also criticized this method. Yeah, so yes, that's right. It needs improvement. Yeah, it's to make sure that our estimation is acceptable. Yeah, that's right, and we need to improve about this. Okay, maybe that's all, Bunuka. Thank you.
Thank you very much, Ibu Ika Yuni, for the response. I think this is it for the discussion session. We already wrap up the question.
Sorry.
Yeah.
I left a question from Pak Aska. It's about the direct.
I also forget. I already read it. How we put the direct estimation in the package?
The variance. Variance.
The variance. Okay.
The variance, yeah. Okay. So wait for a second. Okay. Yeah. We actually built this package based on the reference from the Wakefield and Kismiantini, yeah. And in this package, we employ the input variables. We enter the input variables. This is YE and E and XE. Yeah. So the sampling variance of the direct estimate, I think we don't enter it in this package, yeah, because we only need 3 of these information: YE and E and XE. Yeah. Okay. Thank you. Bunuka.
Yeah. Thank you. I think it's answered the question from Pak Aska. And to wrap up the today's session, I think this is the whole presentation and discussion are very valuable. And I hope that all of you, the audience, can bring something valuable from this session. Thank you very much for presentation from 2 panelists, Ibu Ika Yuni and Bapak Sahrul. Maybe if there are any further question, or there are some of you who needs more clarification, explanation, you can contact them privately to Ibu Ika Yuni and Pak Sahrul. Thank you very much for the fruitful discussion from the audience. This is very helped me so much in the discussion, because I already prepared some question actually, but there are another important question from the audience. So let's meet on the next monthly discussion that will be held by another unit kajian. Thank you very much, and goodbye.